So we have a pendulum that is released to swing freely. On the first swing, the pendulum travels a distance of 18 inches. On each successive swing, the pendulum travels 90% the distance of the previous swing. What is the total distance the pendulum swings? So this is actually kind of trying to get you to understand how to convert a word problem into a geometric series, right? So if this was a geometric series, if we're writing this in sigma notation, what would our first term, our a value be? 18, the first distance. What would our common ratio, our r, be? What are we multiplying by each time? 0.9, right? 90% or 0.9. So if you write this as a sigma, you just have 18 times 0.9 to the end. Hey, it's already from 0, right? Because the first one you would want to just be 18. So our sum is just 18 over 1 minus 0.9, or 180 inches is the total distance swung by the pendulum. Does that make sense? Good. Because there's a couple of those in your homework tonight, just FYI. All right, so this is section 9.2, part B. More practice on determining convergence of series. So today we just go a tiny bit more in depth on geometric series. We have a second warm-up, and these are kind of fun. We are going to convert repeating decimals using geometric series. So the first one that I'm showing you as an example is 0.777777 forever. And the way that you convert this to a geometric series is if you think of it as 0.7 plus 0.07 plus 0.007, right? You're actually adding each digit with its new place infinitely, right? So if you do that and think of it as, well, this is the same as 7 times 1/10, right? Or, 0.07. I really should have done it with 0.7 and then 0.7 times 1/10 and then 0.7 times 1/10 squared. But anyway, I did. So there you go. So you have 7 times 1/10 plus 7 times 1/10 squared times 7 times 1/10 cubed. So the way that I've written it would be starting with an n equals 1, but you only start with an n equals 0. So you do it as 0.7 times 1/10 again. And all you have to do is think my first term, right, goes here, and then whatever I'm multiplying by to get to the next term, that's my r. Does that make sense? So then you just do your a sub 1 over 1 minus r. So 7/10 over 1 minus a 10th gives you 7/10 over 9/10 or 7/9. Do you guys remember back when you were young and you had to convert repeating decimals to fractions, how you did it? No one remember? It's kind of fun. I'm going to show you just in case you want to check your answer because they're kind of fun. Although I think these are all odd number problems anyway, but I still want to show it just because it's fun, right? Okay, so you let n equal 0.7777, right? Forever. And then you just make 10n equal 7.7777 forever, right? And then you just subtract down. So you get 9n equals 7, because all the 0.7s forever will be gone. So your n is 7/9. And since n equals that, right? Isn't that cute? You guys not done that? Really? Oh, it's fun. I thought it was fun when I was young. But, so, anyway, that's the old school way to convert a decimal to a fraction, but we're going to do it the geometric series way to convert a decimal to a fraction. But you can do this to check if you want. So, I want you to take a minute in your groups. This one's a tiny bit harder because it's not just 0.88888, it's 0.818181. So your r might not be a 10th. So just kind of think about it for a minute, discuss amongst yourselves, see if you can figure it out. Bless you. first term would be. And then the next term would be 0.0081. Okay. And if you're going to think about what you have to multiply to get from one term to the next. I have to fix this one too, I'm not sure how I wrote this. Yeah, I don't like this one. Yeah. I'll fix it later. All right, did you get 9/11? C? Good. So your common ratio here was 1/100, and that's what ends up happening is however many digits you have before the next repeat, that's usually how many zeros you have with what you're multiplying by, right? So if it's a 1 digit that repeats, you're multiplying by a 10th. If it's a 2 digit, you're multiplying by a 100th. Okay, 3 digit, you do 1,000th. So, yep. Okay, good. So that's a little part of your homework tonight as well. So you have the word problems from the warm-up, and you have converting decimals. Both of those take up a few of the problems from homework, so I thought I would just expose you to those. All right. This is something new, and this is more kind of the meat of the lesson today. And I'm jumping right in with forcing you to start, but I'm going to give you a little background before I throw you to the wolves, right? So, very common multiple choice problem. I was going through old AP exams trying to find problems on series convergence, and one of the ones that I found a lot happened to match what's in tonight's homework, which is find, and for tonight's homework it's all geometric. The ones on the AP exam have all kinds of different types of sequences, so we're going to revisit this again later on. But anyway, here's what it says. Find all values of x for which the series converges. Then write the sum of the series in terms of x. Before this moment, our series all just had numbers and n. 3 to the n. 4 times 3 to the n, right? Just numbers and n. N was the only letter there. Now we kind of have other stuff. We have x's and n's. So the concept is still the same. If you still look at this as something to the nth power and you think of it as a geometric, then if you remember from our geometric series, the absolute value of r has to be less than 1 for it to converge. Does that ring a bell? So for this, if we think of the 3x kind of like the r, then the absolute value of 3x has to be less than 1 for the series to converge. The absolute value of whatever is being raised to the nth power has to be less than 1 for the series to converge. So the way we write it is, if it's of the form x to the n, which is what a geometric series is, then the absolute value of that thing has to be less than 1, and then you solve the absolute value. So for this one, you would set absolute value of 3x less than 1. Now, I set students loose on this first period, and then there was some, how do we solve an absolute value inequality again, right? So just a quick refresher on how to solve an absolute value inequality. So I'm going to go back to this extra page I made, and we'll do a little more background. So to solve an absolute value inequality, let's just say we have, for fun, absolute value of 2x plus 3 is less than 7, okay? Back in the old days of Algebra 1, the way you had to do this was you wrote 2 inequalities. You wrote 1 just like the original without the absolute value, and then you wrote the other one, and you had to reverse the arrow and change the sign. Now, if we write this out as what's called a compound inequality, you get negative 7 is less than 2x plus 3, which is less than 7. Does that make sense? Since all of our inequalities are going to be absolute value less than 1, they're all going to be at the start as a compound inequality from -1 to 1. And then you can drop your absolute value and just go from there. So now you just subtract 3, so you get negative 10 less than 2x less than 4, and then you just divide by 2. So divide negative 5 less than x less than 2, and there's your interval. All right, so same kind of thing with these. And I want you guys to give these a try. Do as much of it as you can for each one. Feel free to work in your pairs, in your groups, talk to each other, see if you can figure them out.
Wait, what was the significance of all the groups? It was like
Oh.
to converge absolute x.
The absolute value of whatever's being raised to the nth power has to be less than 1. Yep.
Who's a huge for us? Oh, just that, just in that student. Or less than 1.
Make your life easier. You don't have to rewrite it. You're not trying to find the sum. All you're trying to do is show convergence. So just keep it like this. As long as you've got one thing raised to the n, and this, whatever is being raised to your power,
Yeah.
all
All you have to do is find the interval.
You're like, you have one like this.
But you did the first one perfect.
Yeah, I was just wondering what you would do.
No, you just, that's it, that's your answer.
Oh.
Yeah, the answer is just the interval. It's just saying, hey, for what values of x does this converge? So for the first one, oh, I'm sorry, I didn't ask for the sum. Oh, I forgot. Hang on, covering it up, covering it up. There we go. Okay, so that's your interval of convergence. Does that make sense? Okay, now, it also is like a part B. Haha, it said then write the sum of the series in terms of x. In order to find a sum of an infinite geometric series, what does n have to start with? 0, right? Geometric. So we have to rewrite this starting with 0. How do we rewrite starting with 0? What do we do? Plug in the 1, and you get, for this, you get 3x. So that's your new first term. So your new sigma would be that. It's weird, but it's true, right? So you write it starting with 0, and that way you know, all right, my first term, that goes on top over 1 minus r. So you end up with 3x over 1 minus 3x. Okay. All right, the next one's a little bit harder, but not super hard. Give it a try.
Wait, what are we? I'm confused on what we. Oh, okay.
Well, you need to get it in terms of something to the n. Something to the n. We have x to the 2n. How could we write that as just something to the n?
Oh, it's already as.
Go backwards.
So then, what if
You want the n on the very outside.
Negative s squared.
so would it be negative?
Yes.
No,
What's the matter? Oh, you're doing the last one? Oh, okay, so you have the x is better than x squared over x squared is less than 1, right? Okay. Is x squared over x equal to square root of negative? No. So you can actually drop the x value. And you still have a correct inequality. Then it takes some thinking. One of the other things I want to quickly show you, there's a minor difference between an absolute value inequality and a quadratic inequality. And some people are stuck on how to solve a quadratic inequality, right? Okay, going back. All right, so I'm going to label these like extra notes that we were doing first step. So this is for your review quiz. Okay. Whoa, woo. All right. Okay, so next, put a little note here on solving an absolute value inequality. Okay. And now we'll do how to solve. You could do it for any polynomial, but I'm just going to do it for a simple quadratic just so you can see. Solve a quadratic inequality. Okay, so suppose we need to know where x squared plus 5x, let me see if I can think of this right. How about minus 5 is less than 1? All right, so the first thing that you want to do is set it equal to 0. So x squared plus 5x minus 6 is less than 0. Because if this is true, then this is true, right? They're equivalent. So then you want to factor and find your zeros, right? So let's see what we have here. So this factors into x minus 2, x minus, let's see, nope, I'm wrong. X minus 6, x minus 1, x plus 6. All right, so we get our factors. Just find where it's 0. Don't mess with the inequality right now. So I get x is 1 and negative 6. Our favorite friend. Okay, you make a quick sign line. So this works for any polynomial. It wouldn't matter if you had x squared over x squared, if you had an x cubed, right? Find everywhere where it's 0 or undefined, anything that makes anything be 0, put it all on a sign line, and then just find the signs. So this, because it's a positive quadratic, it's going to go plus, minus, plus, but you can test to see. We want to know where this is less than 0, so we're looking for where it's negative. Which means our answer is negative 6 to 1. On the AP exam, traditionally, every single question I've seen like this, they don't use interval notation. They write it negative 6 less than x less than 1, like that. But it's simple. So if you have something funky, like a quadratic inequality to solve, then what you do is find out, like set equals 0, find the zeros, make a sign line, and just use that. Fun. So for this first one, if you want to write it as something to the n, you end up with negative x squared to the n. Does that make sense? When you're setting up inequalities, if you have a negative 1 to the n, in your function, in your rule, the -1, you can ignore it. Because since we were talking about when the absolute value of the argument is less than 1, the -1 will always go away when you have an absolute value. So when you're setting up your absolute value, feel free to ignore the -1, and you could have just done x squared to the n. Right? Does that make sense? So what you really get here is just when is the absolute value of x squared less than 1? Well, x squared is always positive, so you just drop the absolute value. Okay? You just find where x squared is less than 1. Okay, keep going from there. And try the last one too, which is fun. I'm gonna move this over.
I would be happy.
This is, since it's a quadratic, you gotta do it the way I just taught you. Fine, so don't, once you get a quadratic inequality, don't even try to write it as an inequality, find the zeros and make a sign line.
Okay.
Yeah. Mhm. Beautiful. It's just x, not x squared. Because as soon as you factored in that x equals -1 and x equals 1, you're talking about values of x, not x squared. Oh. Okay, but this is incorrect, right? When you have a quadratic inequality, you can't do the little flippy thing. So you've got to find the zero in the sign line and then go to your conclusion. But what is I? Oh,
Because I tried to do the x that way.
So, you have to, instead you gotta do the way that I just taught, which is just ignore this part.
I don't know what you're talking
And think of it like this. So subtract 1 from both sides. Find the zeros. Make a sign line. And then wherever this is true is where it's negative. So it's negative. Okay?
So it's always, it's never gonna be negative.
That's correct. That is a good train to be on. Yes.
I don't know how to put it in.
The last one you could do just by kind of thinking about it. You don't mind it, it doesn't matter.
For your timeline, you got like x in some places.
Oh, like that.
It's a good
When you plug
question.
in, oh, you can plug in 0,
25, we got 20 more minutes.
x squared minus 1.
Isn't it always?
You have to find out when x squared minus 1 is less than 0.
I'm gonna put it in numbers because it's gonna be this, it's gonna be whatever plus 4, so it's always a fraction. But what if it's, what if it's, what?
Wait, so you have your
What
timeline,
if you tell the other fraction?
Beautiful.
and then what do I do?
Oh, here, always set your, is this your,
So like if we're gonna go numbers,
so you start, where is your?
you can't plug in.
Is this it?
42.
Okay. Oh, this was you working it through?
Yeah.
Okay, yeah, this is, no, so, and the absolute value of negative x squared is just x squared, so we just drop it. So here's kind of one of those. So, you can get a better eraser, yeah, it's okay.
Okay, so, all right, and then, so we have, so x squared is plus 1. First thing you do in the quadratic inequality is get everything on one side. Just like if you are solving a quadratic equation, right? You want to do everything set equal 0. And then,
So then that's the first
pretend it's just like a regular old x squared minus 1, where you, so you find your zeros, right? So, 1, and then, so when you're, oh, you have it right there. Okay, so, so anyway, so you get that in your sign line, and you plug in to here, right? Because this is where we got everything from. So if we plug into here, so if x is 10, we're positive. X is 0. And then, since we want to know where this is less than 0, which means where
All right. So this one, the answer is -1 to 1. And since it already starts from 0, you can go ahead and just do a over 1 minus r, but you got to be careful with what your r is, right? Our r is -x squared, which is, so it's important that you have it as one thing to the end so you know what r is. So you end up with 1 over 1 plus x squared is your sum. Is that okay? You look distressed.
So the second part doesn't really transfer to the first, right? So you don't do
From
anything,
here to here?
you don't do anything with the -1 to 1.
Oh, I did. Yeah, because, you mean like this
Yeah.
part of your answer doesn't,
Yeah.
no. But you should know that for, these are the only values of x for which this would be true, right? So really, this is true only if x is between -1 and 1, and it can't equal the endpoints. That's why it's not a less than or equal to kind of a thing. It's only less than. Yes?
Can you show solving the inequality?
Yeah, okay, so when you have a quadratic inequality, so for this one we have this. Is everyone okay with how we get to there? X squared less than 1? Yeah? So we have a quadratic inequality. First thing that you do when you have a quadratic inequality is get everything on one side. Alright, you want to find the zeros of this. I'm going to do it by factoring, but most of you could just look at this and say it's -1 to 1. Either way. Alright, let's fix it. Alright, so now, hang on. It's because it's grouped with that check mark that it wasn't unclear. Alright, okay, so now we make a sign line. -1, 1. You're plugging in here. You're plugging into the one where you have it, the inequality in terms of 0. So if I plug a -10 in, I get 100 minus 1, which is positive. If I plug a 0 in, I get -1, which is negative. If I plug a 10 in, I get a positive. I want to know where this is less than 0. That would be where you have a negative on your sign line. And so it's from -1 to 1. This one is fun and tricky all in one. So you have x squared over x squared plus 4. If you were to do this with an absolute value, x squared over x squared plus 4, is it ever negative? No, because you have an x squared, and if you have an x squared plus 4, right? So it's never negative. Need to expand. Where's the bottom? Am I just making it bigger? No, there's the bottom. Okay. I'm going to drop the absolute value. So I get this. Now, here's the trick. I did this by thinking about it. So I didn't actually spend the time to solve it. If you take the time and think about it, you know the bottom is always bigger than the top, and the whole thing is always less than 1, just by thinking about it. Because you take something and then you take itself and add 4, right? Something that's positive, right? So it's always true. All right, if we were to do this properly, and I will do it properly really quickly. So you have to write it as a rational, so x squared minus x squared plus 4. So you get x squared minus x squared plus 4 over x squared plus 4. Let's go away. All right. So if we go with this, we get, that's gone, we end up with negative 4 over x squared plus 4 is less than 0. Is the bottom ever equal to 0? No, and you can show that by trying to solve it. It doesn't factor. You set x squared plus 4 equal to 0, you get x squared equals negative 4, which can't happen, right? So there's no zeros on the bottom, there's no zeros on the top. So you have a sign line with nothing on it. This whole thing is just one sign. And what is that sign? That sign is negative. Which means this thing is always true. True for all real numbers. So there's your analytical way of proving it. But if you can just look at it and think about it, that's fine, right? That's fine. So there's nothing wrong with looking at it and thinking about it. So when I did this one, that's what I did. I just said, hey, look, this is always less than 1. So there you go. So it's true for all x. So you could have like negative infinity less than x less than infinity, like something like that. Okay, but then you still have to write it starting with 0 and blah, 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 blah. Find your sum, which is x squared over 4. Questions? Yeah, it's a lot. But it won't feel like a lot. Once you kind of start doing them, they really aren't so bad. It's just that, to me, like this was simple because I am comfortable with solving quadratic inequalities and absolute value inequalities. For you guys, you've done it. It's just been a while, right? So you're having to pull out skills you haven't used in 3 or 4 years, and so that's what makes it feel harder than it is, right? Once you brush off the cobwebs, it'll feel easier. So, all right. Okay, this is an actual AP exam problem from 1993. I want you to try it. Remember, this is just a simple linear inequality. You don't have to do the whole sine line quadratic thing. When it's a linear inequality, life is easy. Oh.
Think of it as one thing to the end. The first thing you always want to do is rewrite it so that you just have one thing to the end. This is an N, right? Yeah, there we go. Yes, and there's no squares. Exactly. Yeah, you're making it harder than it is, yeah. That's okay. Wow, both of you are eraserless, all right. Perfect, beautiful. Now can we solve? Oh, and you don't have, whenever you're writing this, you don't put the end here. It's whatever's being raised to the end, that's kind of like your causing ratio, that's the first thing.
I think it's always less than.
Oh, yeah.
This one should be.
No, I'm just trying to find your
Just
word.
look at the board, there's only one answer, because they're all less than or equal to. Except that one.
Is this your, oh, I see it. I see it. It's just it's faint. Kind of see it. Is this a negative one? Is that a less than one? Tell me what you're gonna do. No. Yes, it is. Yes, that's beautiful. Okay, so we're not trying to find a sum. We're just trying to find the x's where it converges, yeah. Perfect, perfect. Now from there you solve it. Good. Who else needs me to come by and take a look? Okay. Glenn, what'd you get?
We got C.
You got C?
Yes.
I like that you said we. That's very good, right? Include the partner. Yes, we got C. That's good. Yeah, there's nothing weird about it. It's good. Yeah. Okay. Yes. Did anyone not get C? Everyone got C? Okay, that's good because the answer is C, right? So I saw a few issues with setup. Be careful when you're doing this that you think of this as the sum of x minus 1 over 3 to the n. So you get absolute value of x minus 1 over 3 less than 1. As long as it's linear, you don't have to do that whole sign line thing, right? Don't start going there for everything. So instead, linear inequality, if it's a less than, you can just jump right to this. Right? Is that okay?
Yes.
Good. Okay, multiply by 3. And then add 1. Does that make sense? Good. Be in the habit, when you have linear less than 1, of just jumping right to -1, less than that, less than 1, and then just do the algebra from there. Okay. Fun. All right, we're going to backtrack a little bit. We're going to have some fun with limits. I want you in your groups to take about 3 or 4 minutes and see if you can figure out all 6 of these limits. Some of them you can do really fast. You can just look at them and figure it out. Some of them take a tiny bit longer to prove. You don't really have to prove them as long as you find them. That's okay.
One second.
Don't forget about that comparative growth rate method.
So one, okay, so.
Yeah. Yeah. X to the infinity over infinity. Yeah.
Natural law for gross, natural law of 100, natural law of
Yeah, I would encourage that, it's very good.
Oh, because it's the time that you have to like.
Okay, go ahead and go to lunch, and we will finish this up when we get back. I'm gonna just kill the tape.